welcome to another practical session with Mr. Moses. So today we'll be looking at an experiment which is titled the verification of Hooke's law of elasticity. Now in this experiment, our aim will be to determine the stiffness or the spring constant. Some years ago, Robert Hooke proposed a theory which states that provided the elastic limit of an elastic material is not exceeded, the extension E is directly proportional to the force applied, meaning that the force applied on a spring gives an extension on that spring which is proportional to the amount of force exerted on the spring. So the spring is meant to expand proportionally with the amount of force exerted on the string. So today we'll be using some set of apparatus to be able to determine the Hooke's law of elasticity. We'll be able to verify the Hooke's law of elasticity. So please join me on this sweet ride as I take us on the practical to determine the stiffness of a spring and to be able to verify the Hooke's law of elasticity. So next, I'll be showing us the set of apparatus that we need to carry out this experiment. So guys, in this practical session, we will be making use of some set of apparatus to verify the Hooke's law of elasticity. The first of them that we'll be using our spring balance. We will also need our retort stand and the clamp. We also need our meter rule. We'll be using sets of masses. This is 50 grams, this is 10 grams, this is 20 grams, this is 5 grams. Then we'll be using our spring. So these are the apparatus that we need to verify Hooke's law of elasticity. So having this experimental setup, we will have to take the initial reading of the indicator. Now the initial reading of the indicator, as we can see, is 58.7. 58.7. So we record that one as our x1. So we are going to do this experiment for 5, 10, 20, 30, 40, 50, and 60. I picked 5, 10, 20, 30, 40, 50, and 60. So I'm going to put my 5 gram mass on it. Okay, this is my 5 gram mass. Okay, after putting my 5 gram mass on it, the indicator is still indicating 58.7. 58.7. Okay, so I will remove it. We record this 58.7 as my x1. I will remove it and put it again and see what the indicator tells me. The indicator is still giving me for x3. I'll record this second reading as my s3, which is 58.7. Then I'm going to go to the next one, which is 10. I'm going to add my 5 gram to 5, which will give me 10, or I can just use my 10 gram directly. Let me try and see. Okay, this is my 10 gram. Okay, this is my 10 gram. While I use my 10 gram directly, the spring is still giving me 57. What I have here is still 58.7. 58.7. Or let me try the second point and see. Let me use 5 plus 5 gram, which is 10. See what I have. Okay, it's still 58.7. So the next, I want to add I want to get my 20 gram. So for 20, I'm going to add this So after adding that, I have 58 is giving me 58.8. For 20 is 58.8. I remove it and I'll put it again. The indicator is 58.8. Okay, now the next one is going to be 30 gram. Next one is going to be 30 gram, and I'm adding my 20 gram plus the initial 10 gives us 30, so this is 30. Okay, at 30, let me see where the indicator is taking us to. Properly set the indicator so that you'll be able to. So at 30, it gives me 59.0. So at 30, it gives me 59.0. Then I will remove it and put it back again. 59.0. So the next one is still the same thing, 59.0. So the next one I'm going to do for my 40 gram. So this is 20. So if I had 10 gram to eat, if I have my 10 gram to eat, this will give me 40 gram. So I'm going to add my 40 gram to it. So what I'm having for the 40 gram, let me see what the indicator is giving me. Okay, the indicator is giving me 59.6. 40, 59.6. Then I will remove it again and do that again. It still gives me 59.6. Then I'm going to carry out for the 60. I'm going to carry out for 60. Then I'm going to remove this. I'm going to carry out the experiment for 60 gram. For 60 gram, I'm just going to add for 50 gram. I'm just going to add the another 20 gram to it. So if I add another 20 gram to it, this is a 20 gram. So let me add 20 gram to it. So this is 20. 20 plus 20 plus 10 gives me 50. So for 50 gram, this is giving me, the indicator is showing me, I'm trying to ensure I get it properly. So for 50 gram, this is giving me 60.6. So this is the table of value for our experiment, where we have our SN from 1 to 6. Then we have our masses in gram, 5, 10, 20, 30, 40, 50. Then we have our initial reading as the first reading as x2, and the initial reading of the pointer, which is x1, giving us 58.7. Then we have the second reading, which is x3. Then we have our e1, which is x2 minus x1. You can see the table. We have e2, x3 minus x1, and we have the average extension, which is e1 plus e2 all over 2. This is our table of value for the practical. So using our experimental setup, you can be able to get a similar table of value. Then after this, in the next video, I'll be showing us how to experimentally using our graph sheet to plot the graph for this experiment. So guys, I've been able to walk us through the step-by-step process that we need for the verification of Hooke's law of elasticity and to determine the stiffness or spring constant of any spring. So this is the experimental procedure, and if you do the same process which I have taught you using the practical session, you'll be able to arrive at similar table of values. So in the next video, I'll be taking us into how we can plot our graph and how we can find the stiffness or the force or spring constant. So bye bye, see you next in our upcoming video on the graphical analysis and the determination of the spring constant. See you next time. Bye.